Okay, today we're going to start Chapter 3, Inequalities in One Variable. So this is Section 3.1, Linear Inequalities. So what is a linear inequality? Well, if we remember, we get one solution to the equation that makes the equation true. So for example, x equals 65 is a solution for the equation x minus 61 equals 64. And what we've done is basically we've added 61 to both sides to do that. So we've added, we've added 61 here, we added 61 here, and we solved and we get x equals 65. Now, with inequalities, we're going to have an inequality symbol, and we have several of these below. We have over here on the left, we've got the greater than, then we have the less than, then on the right, we have the greater than or equal to, or the less than or equal to. So we're going to have basically relations between two numbers using one of these four symbols. Now, linear equalities in one variable, they're going to look at like the form ax plus b is less than c, or it could be greater than or greater than or equal to or less than or equal to. So any of the inequality symbols we can replace here with this less than. So but this is the general format. We have the ax plus b, one of the inequality symbols, and c. Now, with the linear inequalities, we're going to basically get an interval of numbers that makes our inequality true. So, for example, x less than 6, that's the interval of numbers that makes the inequality to this inequality true. So if what we do here was we subtract 9 from both sides, and so x is less than the 6, okay? And so that's how we got this x less than 6. Now we're going to write in interval notation usually what we have for the solution, and we represent the inequality symbols with parentheses and brackets when we convert the inequality to interval notation. So for the x less than 6, what we have to do is we have to think about where that is. And sometimes doing a number line is going to be the easiest way. And so, we have, here's our 6, and it's going to be less than. So either we have an open circle, sometimes we have parentheses, depending on how you want to do it. And it's going to be everything that direction. And so basically we're going to go from negative infinity up to 6 and then a parenthesis. That's because we have the open circle, and that would be a parenthesis. We could also put a parenthesis at this point instead, and sometimes that's how the notation will be shown. Now, if we're doing interval notation, that's kind of what I just showed you there. Here we have the x less than 6. So that's equivalent to the set of numbers in interval notation from negative infinity up to whatever that a is, and then a parenthesis. And that's because we have just this strictly less than. Now, if we had the less than or equal to, what we have then is a bracket. So on our number line on the previous example, if we would have had x less than or equal to 6, well, then at that 6, we're going to have a closed circle and going down. And so that means it's going to include that 6 value, whereas here it's not including it, it's just less than that number, but the less than or equal to includes the 6. And so then we would have the 6 here with the bracket. And so that's what we would have here. It would go still from negative infinity up to 6, but now we would have that bracket. And another way to graph this would be a bracket here instead of the closed circle. Now, if we have x is greater than a, then the equivalent set of numbers in interval notation is going from a to positive infinity, and that would be something like if we had, x is greater than 2. All right, well, if we look on a number line, how does that work? Well, here's our 2, and it's everything greater than that, so it's not equal to, so we have the open circle, and it's everything to that direction, so we're going from 2 to positive infinity. And so here we'd have going from parenthesis 2 to the positive infinity. Now, if we would have had x is greater than or equal to, say, a 3, well, here we could say that's our 3. And so greater than or equal to is going to give us a closed circle. And so we're going to go from that bracket, then 3 comma positive infinity. All right, so note the greater than and less than will utilize parentheses. So whenever we have just the greater than, or when we had on the previous page, we had the less than, those are always going to have parentheses. When we have the greater than or equal to or less than or equal to, those are going to be the brackets. Or, if we're doing drawing, we can also do a closed circle. Okay. Now, whenever we have the infinity, no matter if it's the negative infinity or the positive infinity, we always use the parentheses, as we can see up above here. So, the strictly less than is a parenthesis, the strictly greater than is a parenthesis, the less than or equal to is a bracket, and a greater than or equal to is a bracket. Okay. So we've kind of talked about this already to try to kind of explain how it is. And what we're doing is we're graphing the inequalities and then writing in interval notation. So what we do is we draw a number line, mark the number that is in the inequality on the number line. Then we put a parenthesis or a bracket or the appropriate dot on the number line. So open or close circle. And again, remember, the greater than or the less than uses parentheses or open circles when we plot it. And a greater than or equal to or less than or equal to, that uses a bracket or a closed circle. And then we just draw the arrow in the direction where the solution lies, and then we can write the inequality in interval notation. And this is how we kind of, that graph usually is aiding us to write that interval notation, because we can kind of see it on the graph a lot easier than just as an inequality. So here, what we're going to do is we're going to graph the inequality, and then we're going to write it in interval notation. So if we look at this, we have first to graph it. Now let's say here is a -2, and k is less than or equal to a -2. So this time we have to kind of read it backwards. And so less than or equal to, so here we're going to have a closed circle, and less than or equal to goes that direction. Now we could have also used the bracket and gone in the same direction and had the same thing. So again, closed circle or bracket, and that will be the representation graphically. Now, if we think about the interval notation, well, we're going from this direction all the way over here. So that's going from -infinity up to the -2, and then we have the bracket. So sometimes the bracket's nice because we know, oh, we have to have a bracket here, but closed circle represents a bracket as well. And so that would be our interval notation. Now for this one, x is greater than a -5. Well, again, if we draw our number line, say that's our -5, we're going to be greater than that. Now it doesn't say equal to, so here we have to have an open circle and everything to the right. Now we could have also had a parenthesis and everything to the right if we wanted to use parentheses instead of the open circle. I like to use open circles, so eventually when we do this, I'm going to use only open circles or closed circles depending on, the appropriate circle type. And so here we're going from a -5 all the way up to positive infinity. And here we have a parenthesis because we have the open circle, or in this case, the parenthesis as we draw it because we don't have less than or equal to, or greater than or equal to. Now we're given the graph, and what we have to do is write the equivalent inequality and the interval notation. So what we have to do is we have to go and we have to write something like this as well as something like this. So we're given the middle piece and we have to write those two edge pieces. All right, so what do we have? Well, we have a bracket, and so we know we're going to go from the 1 all the way up to positive infinity because we're going from here that direction. And so what does that say? Well, that says x is greater than or equal to 1. Now this one's not too much different, except now we have a parenthesis and it's still going the same direction. So we're not changing anything there. So we're going from a -2 to a positive infinity. And because it's just the parenthesis, that means it's just x is greater than -2. It's not equal to because we don't have the bracket, but it's greater than. And so that would be what we need to write for that one. Solving linear inequalities. So we also can solve them, and we have two properties that are going to help us solve them. And we've seen these properties before as the addition property of equality and the multiplication property of equality. Now, what this says is for numbers a, b, and c, if a is less than b is equivalent to a plus c less than b plus c. So basically what we can do is we can add the same thing to both sides of the inequality, and it doesn't change the inequality. So adding the same thing doesn't change this. Now we can also use the other three inequality symbols here, and it doesn't change anything as well. It just means we're going to use those different symbols here. Now that's the addition one. Now multiplication's a slight bit different because with equality, it doesn't matter. We can just multiply both sides by the same thing, like, and multiply by a c, and it doesn't change it with the equality. But with inequalities, it does change it because we have two cases, c greater than 0 and c less than 0. So for the first one, c greater than 0, so basically a positive number, then we can say, well, a is less than b is equivalent to a times c less than b times c, and basically we are multiplying the same thing on both sides of the inequality, doesn't change the inequality. Now, if c is less than 0, that means it's going to be a negative number, and when we multiply by negatives, we have to change the inequality symbol, and so it goes from less than to greater than. And so that's the key with multiplying by negative numbers, and so we have to remember that. And so that's going to be the key difference here. So when we multiply by negative on both sides, we have to change our inequality symbol to face the other direction. So if it's initially less than, we have to change it to greater than. If it was initially maybe greater than or equal to, we have to switch it to less than or equal to. Then we have a special thing called tripartite inequalities. And so this is an inequality where the variable or expression containing the variable is between two numbers. Now to solve these, what we have to do is we have to apply the two properties of inequalities to all three pieces. So what we have is we're going to have something like a less than x less than b, or we can have less than or equal to signs, or we can have whatever we have, but we have a tripartite. We have 1, 2, 3 parts basically. Okay, now this middle part here, when we have it in this form here, that's our solve for x. But what happens is, to get to that, sometimes we're going to have to apply, the properties. We're going to have to divide by numbers, we're going to have to multiply by numbers, we're going to have to add numbers, and when we do it, we have to do it to all three parts here. And again, it doesn't matter what our inequality symbol is, it's just going to be doing it on all three parts. And then at the end, we're going to figure out what we have to do. So when we have this less than and less than like this, basically we're saying the equivalent in interval notation is x is going to be between a and b, but it's all going to be in parentheses. So a to b, all in parentheses. Now, if we had the less than or equal to, less than or equal to, then it's going to be bracket a comma b bracket. Okay, so then it's going to have the brackets around it. Now we can also have one side is a bracket, one side is just a parenthesis, and so that's what it would look like here. And we can switch it around and have the other side be the bracket and this side be the parenthesis, and so that's what it would look like. But again, we have to solve it to get that x in the middle, so we might have to add or subtract everything on all three pieces, and we might have to multiply or divide all three things on all three parts. Now remember, when we multiply here, when you multiply by a fraction, say maybe multiply by a third, that's the same thing as dividing. So if we had, say, something like 3, 3 is less than 4, we could say, okay, well, we can multiply by, 2, multiply by 2, and 6 is less than 8. Or we could say 3 is less than 4, and we could say, well, we could divide by 3 and divide by 3. So 1 is less than 4/3, and that's still the same. So, we can multiply or divide, and it works. And really, when you think about dividing, what you're doing is you're multiplying by that 1/3 is what it is. And so that's why we just say only the multiplication property, because you can multiply by fractions. All right, so what we're going to do now is solve some inequalities. We're going to graph the solutions and then write the solution in interval notation. All right, so what we need to do is we need to solve for the variable basically on one side. So we have 2 plus r less than 3. Well, we need to get rid of that 2. So I'm going to subtract 2 on both sides. On the left, I have r still less than 3 minus 2 is 1. So now I've got the inequality solved. And so now I'm going to graph it. So I put my 1 on here, and it says r is less than 1. And it's going to be an open circle. It's going to be less than 1, so it's going to go to the left. So that's my graphing of it. And if I rewrite this, that's going from negative infinity up to 1, and then we have a parenthesis because we have the open circle. Okay, and so now I've got my interval notation, I've got my graph, and I've solved the inequality. All right, on the next one, there's several things we could do. We could distribute and then simplify from there. Or let's just have, since it's already broken down like this, let's divide both sides by the 2 to get rid of it. And so when we divide that, those cancel, and we get 3 plus k is less than. Now 44 divided by 2 is 22. Okay. Now we just have to subtract 3. And now k is less than. Well, if we subtract there, well, if we have to borrow, and now we have 9 and we have a 1, so k is less than 19. Okay. Now, let's say we have 19. Now here it's less than that, so we have an open circle because it's not equal to, and it goes like that. So we're going from negative infinity to 19, parenthesis, and so that's in interval notation. So we've graphed it, we have an interval notation, and we've solved the All right, so these are getting a little bit more difficult. Now these, we can't just say, okay, we're going to divide or multiply on both sides. What we have to do is we actually have to distribute, get rid of parentheses on both sides, and then start getting the variables on one side and the numbers on the other, and then simplify from there. So we're going to have to distribute first here, and we'll distribute here. So that gives us 4 plus 2a plus 10 less than, here we have a negative 2 times a negative a, so it's going to give us 2a. We have a negative 2 times a negative 4, it's going to be plus 8. All right, so this looks like we have now 4 and 10, so we have 2a plus 14 less than 2a plus 8. Well, let's take the a's to the left, so minus 2a, and now we have 14 less than 8. Well, that doesn't look like that's possible because 14 is greater than 8. So we say this is false, and so there is no solution. So sometimes when we work these, we get something like this. We get no solution. And so when you get something that doesn't make sense, it's not a true statement, we just say it's false, and then we have no solution. And another way sometimes is they'll write no solution as a circle with that slash through it. All right, what about the next one? Here we have 2 is greater than a minus 2 over 5. Well, let's get rid of that 5 first. So we're going to use the multiplication property and multiply both sides by a 5. Because when we do that, those cancel. So on the left, we have 10 is greater than a minus 2. So those cancel, we don't have anything else. So now we add 2 to both sides. So we have 12 is greater than a, and so now we've solved our inequality, so we've done the first thing. Now we have to graph it. So here, 12, so a is less than 12, no equals to, so it's an open circle, and everything to the left. And so if we write this, that's going from negative infinity up to 12, and that's a parenthesis. So we have our interval notation, we have our graph, and we have our solution. So notice we didn't have to graph anything here because there's no solution. So there will not be a graph or an interval notation. You can write no solution or the empty set.